So let's start the lecture. So first, let's start with exercise. The first exercise is if E is nowhere dense in R1, if E is nowhere dense in R, okay, if E is nowhere dense in R, so nowhere dense means interior of E closure is the empty set. Prove that any subset of E is nowhere dense. Oh, that's trivial actually. Any subset of E is nowhere dense. Okay, any subset of E is nowhere dense in R. Second one, if we have a sequence of countable number of subsets of R1 and each En is a first category, then their union is first category. Let's write it like this. If n runs from 1 to infinity is a sequence of first category sets, sequence of first category sets, then show that union En runs from 1 to infinity is also a first category, first category. First category means which can be expressed as countable union of nowhere dense sets, is also a first category. Next exercise is prove that any non-empty open interval of R1 is of second category. Prove that any non-empty open interval of R is of second category. So this is very simple. This one. Fourth one is, so this list is on the book Goldberg, exercise 5.6 actually. Let's take if we have sequence of open subsets of R, each of which is dense. Okay, open subsets of R and each of which is dense, then you need to show that the intersection is also dense. If G1, G2 be dense, they're all dense in R. Dense in R means that their closure is equal to 4 of R. You prove that the intersection is also dense. Prove that intersection Gn and runs from 1 to infinity is also dense in R. So it is you have to apply the preceding two exercises. Apply preceding two exercises. Okay, So apply these two exercises, you can find out the solution. Okay, think over these exercises. So next we have a definition. That's the definition of characteristic function. Definition. Let's define this function. Let's define, notation is by chi. It's from R to R. This be a function. Which is defined by chi of x is 0 if x is rational. And it's 1 if x is irrational. It's 1 if x is rational. This is, I think, directly function which is a well-known function. It's no it continues this function. You can easily verify, because the reason is that rationals and irrationals, they are both dense in R. Okay, so it is 0 if x is rational, and it's 1 if x is irrational. Okay, if x is not rational. So let's define this function. Okay, this function is called the characteristic function of the irrationals, क्योंकि irrationals पर इसका value 1 है. This function is called the characteristic function. Characteristic function of irrationals. Function of set of irrationals, or you can simply write irrationals. Okay, so ये आपको पता है this is nowhere continuous है, या वो मैं बता दूँ, explain करूँ इसको. So reason वो मैंने बता दिया, because rationals are dense in R and irrationals are dense in R. So we have in this direction we have the final theorem actually, which that we have to in this topic, the discontinuous function is an R. That's the final theorem, and the theorem is the following. There is no sequence fn of functions, continuous functions. In fact, there is no sequence fn and runs from 1 to infinity of functions, of continuous functions. Okay, of continuous functions on R. So they are functions from R to R. Okay, and each one is f1 is a function from R to R. It is continuous. f2 is a function from R. All of them, they are functions. They are continuous functions. Okay, from R to R. So we have to show there is no such sequence, which the sequence of continuous function is such that this limit and approach to infinity fn x is equal to this characteristic function. This is called the limit function, such that the limit function of fn x is the chi x, the characteristic function. So this is true for each x, means minus infinity less than x, less than infinity. X is an R. Okay, so limit, you know, तो लिमिट का मतलब यहाँ पर क्या है. लिमिट आपने एक्चुअली सीक्वेंसेस कर लिया है, नॉट द फंक्शंस है. सो उसको मैं पहला थोड़ा सा एक्सप्लेन कर दूंगा. सपोज आप आप पॉइंट को फिक्स करोगे. लेट्स टेक x इक्वल टू 1. ओके, then let's find this fn1. It's a real number. fn2, it's also a real number. Sorry, let's write this. For x equal to 1, we have the following sequence, which is f11, f21, f31. So they are all real numbers. So we have this sequence of real numbers. Suppose it converges to some point, this sequence. Say, let's for instance, it converges to say y1, okay, because you are calculating it at point 1, okay. So इनपुट आपने 1 दिया है. इसी तरह से पॉइंट 2 पर आप देखोगे आपके पास एक नई सीक्वेंस आ जाएगी, x इक्वल्स टू f12, f22, so on and so forth. Suppose ये भी किसी पॉइंट पर कन्वर्ज करे y2. Obviously ये y1 it may be equal or may not be equal to y2. So and one thing is clear that this y1 it depends on one जो पॉइंट आप चूज करें. आप पॉइंट को वैरी करोगे, you may get the different limits of these sequences. So this y1 it depends on 1, you can see. This y2 it depends on 2 actually. ये 2 की मदद से आपको ये वैल्यू. इसी तरह से आप पॉइंट्स को वैरी करते रहोगे. आपसे इन जनरल आप लोगे आप x, आपके पास आप ये सीक्वेंस है f1x, f2x, so on and so forth. You will get this sequence and this will converge. Suppose this sequence will converge, से ये किसी पॉइंट पर कन्वर्ज कर रही है, से y. Obviously वो जो y होगा ना वो किस पर डिपेंड होगा, वो x पर डिपेंड होगा. So that y is a function of x, you can see. अब function of x क्यों होगा, क्योंकि यूनिक होगा ये y, because this sequence converges to y and y is the unique. लिमिट इज द यूनिक. सो दिस ये जो y होगा हर किसी पॉइंट पर आपको कोई ना कोई वैल्यू मिलेगा ना. तो वो वैल्यू जो होगी वो वैल्यूज एक्चुअली वो कोई फंक्शन ही बनाएगा ना. दैट्स अ फंक्शन, सम फंक्शन विच वी कॉल द लिमिट फंक्शन. और इस केस में आपके पास क्या है, यू हैव अ सीक्वेंस ऑफ कंटिन्यूअस फंक्शंस एंड द लिमिट फंक्शन इज x, कैरेक्टरिस्टिक ऑफ x, कैरेक्टरिस्टिक फंक्शन ऑफ दिस इरेशनल्स इस केस में. और आपको प्रूव करना इट्स नॉट ट्रू. वी कैन नॉट फाइंड द सीक्वेंस ऑफ फंक्शंस व्हिच इज द सीक्वेंस ऑफ कंटिन्यूअस फंक्शंस सच दैट द लिमिट फंक्शन ऑफ दैट सीक्वेंस इज द कैरेक्टरिस्टिक फंक्शन ऑफ इरेशनल्स. सो दैट्स नॉट ट्रू. वो आपको प्रूव करना है. दिस इज नॉट ट्रू. Okay, so let's prove this theorem. आपको ये बात समझ आ गई, कन्वर्जेंस ऑफ द सीक्वेंस का मतलब क्या, इट कन्वर्जेस टू chi of x. कैन टेक एनी नंबर ऑफ एग्जांपल्स. आप कुछ एग्जांपल्स भी आप ले सकती हो. जैसे इफ यू टेक दिस एग्जांपल, लेट्स डिफाइन दिस सीक्वेंस fn x इक्वल टू सी इट्स इक्वल टू 1 प्लस x पावर n लाइक दिस. ओके, वायर माइनस इन्फिनिटी लेस देन x. सो अगर आप अगर आप fn1 देखना चाहोगे, fn1 क्या होगा, 1 प्लस 1 पावर n दैट्स इक्वल टू 2, राइट. सो f1 भी 2 है, f21 भी इट्स अ कांस्टेंट. तो ये जो सीक्वेंस ऑफ फंक्शंस है इसकी जो पहली टर्म है ना, इसका जो x पर वैल्यू 1 है ना, इट गिव्स अस अ कांस्टेंट सीक्वेंस. इट्स अ कांस्टेंट सीक्वेंस. इस तरह से अगर मैं x का वैल्यू 2 दूंगा, व्हाट विल बी fn2, it's 1 plus 2 power n. Now this is not a constant sequence and this sequence diverges to infinity. अब आप कहोगे ये तो डाइवर्ज करे, हमने वहाँ पर कन्वर्जेस लिया क्योंकि वो हमारी assumption है. Suppose it converges to chi of x, it's our assumption that it converges for each x it gives us some finite value. So let's take the point where it converges. So let's take this point fn say 1 by 2. What's this? It's 1 plus 1 by 2 power n and that converges to 1. तो कुछ पॉइंट्स ऐसे हैं जहां पर ये कांस्टेंट सीक्वेंस है, ऑब्वियसली इट कन्वर्जेस टू द सेम थिंग बिकॉज इट इज द कांस्टेंट सीक्वेंस, इट कन्वर्जेस टू. और कुछ पॉइंट्स ऐसे जहां पर ये डाइवर्ज कर रही है, और कुछ पॉइंट्स ऐसे जहां पर सीक्वेंस का कांस्टेंट नहीं है बट स्टिल इट कन्वर्जेस टू सम पॉइंट से 1 हियर. तो इसी तरह से आप डिफरेंट पॉइंट्स चूज करोगे तो हर टाइम आप देखोगे ये जो लिमिट है ना ये एक्चुअली इस पॉइंट पर ही डिपेंड करता है. सो इट्स अ फंक्शन ऑफ दिस पॉइंट. तो वही मैं आपको एक्सप्लेन कर रहा था कि लिमिट ऑफ fn x इट्स अ फंक्शन ऑफ x. सो हियर इट इज द कैरेक्टरिस्टिक फंक्शन ऑफ x इन आवर थ्योरम. proof of this theorem. Suppose assume on contrary that there is a sequence of continuous functions which converges to this characteristic function of rationals. Assume on contrary that there is a sequence of continuous functions fn such that limit n approach to infinity fn x is equal to chi x. It's the characteristic functions of rationals there. Characteristic function of irrationals. Okay, so assume this is true. There is some sequence. So by this assumption we show that set of irrationals जो है आपका irrationals का set हम prove करेंगे वो first category है. So वो हम एक contradiction, because we know that set of irrationals is of second category. हम इस assumption से ये prove करेंगे set of irrationals is of first category. Yeah, is of type f sigma हम prove करेंगे. Sorry, we will show that a set of irrationals is of type f sigma. We know that set of irrationals is not of type f sigma. वो हमने कर दिया है. It's not of type f sigma, but by this assumption we will see that the set of irrationals is of type f sigma. So which is the contradiction actually. So is of f sigma means that we need to show that set of irrationals is the countable union of closed sets. So we need the construction, we need the closed sets actually for this. तो वो closed sets हम कैसे define करेंगे? That's very important. This we have to use this continuity, in fact, because we need to show that there is no sequence of continuous functions. So we have to apply this continuity because we have now this sequence of continuous functions, and the property of continuous functions are in the metric spaces. In fact, in topological spaces, the inverse image of closed sets is closed, or inverse image of open sets is open set. If we have a continuous function between two topological spaces, then this f is continuous if the inverse image of open sets is open, or equivalently if the inverse image of closed sets is closed. So same is true in the metric space, because topological space is the generalization of metric spaces. So same is true for metric spaces. If we have two metric spaces, say x and y, and we have a function from x into y, then this is continuous if and only if the inverse image of open sets is open or the inverse image of closed sets is closed. तो यहाँ पर fn जो है ना, it's a function from R to R, and R is a metric space with respect to the usual metric. It's also topological space. So this fn is continuous means that the inverse image of closed sets is closed. So since fn from R to R is continuous for all n greater or equal to 1, therefore inverse image of closed set under this map f, okay, under fn is closed. That is fn inverse f is closed whenever f is closed, whenever f is closed, for all n greater or equal to 1. ये आपको समझ आ गया? ये जो लाइन मैंने यहाँ पर लिखी, f n inverse of capital F is closed whenever f is closed. यहाँ पर इन आर लिखने की दोनों साइड से आपका स्पेस सेम है, बोथ आर रियल स्पेसेस हियर. f n is a function from r to r. So they are closed. Okay, inverse image of closed sets are closed. Now for each n, let's define this. For each n, greater or equal to 1, define this set E n. Okay, it is a set of the points of R, those points of R, such that the image under Fn, because it depends on nx here, okay, such that image of x under Fn is greater or equal to 1 by 2. That is your En is actually the inverse image of this set Fn inverse greater or equal to 1 by 2. Okay, means that it's the inverse image of this set. So En is actually this inverse image of this set. आप इसको प्रूव कर सकते. Let's take any x here. So x here means that fn x belongs to 1 by 2 to infinity. That means fn x is greater or equal to 1 by 2. And whenever fn x is greater or equal to 1 by 2, it means that x belongs to f inverse 1 by 2 to infinity. So that means they are actually the same sets. So but this set, the closed and 1 by 2 to infinity, it's a closed subset of R. So therefore its inverse image must be closed. So therefore En is a closed set, in R for all n greater or equal to 1. En is closed. And also you know that the arbitrary intersection of closed sets is again a closed set. So now let's define capital Fn. Okay, let's define this set capital Fn, which is the countable intersection of closed sets, which is this set, which starts from En intersection En plus 1 intersection, so on and so forth. So that's actually the intersection of these sets. En runs from capital N to infinity. Okay, where this capital N is what? It's greater or equal to 1. So if capital N is 1, then it is F1. F1 means E1 intersection, E2 intersection, so on and so forth. And if capital N is 2, then it will be E2 intersection E3. So E2 से start होगा उस केस में. So this is here intersection of En. So we know that intersection of closed sets is closed, whether it's infinite intersection or finite intersection. So then each Fn is a closed set. Each F capital N is a closed set in R. तो क्लोजर सेट्स आपको मिल गई R की. अब आप प्रूव करोगे क्यूब कॉम्प्लीमेंट जो है सेट ऑफ इरेशनल्स. वी शो दैट क्यूब कॉम्प्लीमेंट इज union of these closed sets. Okay, that means Q complement is the countable union of closed sets, and we know that that set which is the countable union of closed set is called F sigma set. In other words, we are proving that Q complement, the set of irrationals, is actually F sigma set. Yeah, हम prove करेंगे. So first let's take any irrational number. We will show that that's in some fn. Let x belongs to q complement. Then by our definition, what's this limit? It's given that limit n approach to infinity fn x is equal to chi of x. This is given, but x is irrational, so chi of x must be equal to 1. So that means limit n approach to infinity fn x is equal to 1. Okay, right? This limit is equal to 1. So what can I do then? Then for each epsilon positive, I can find some capital N such that mod of fn x minus 1 is less than epsilon for all n greater or equal to the capital N. So let epsilon be any positive number. Let epsilon be any positive number. Choose capital N greater or equal to 1 such that mod of fn x minus 1 is a limit is less than epsilon for all n greater or equal to capital N. Okay, this is so this gives the following. So in particular, it's true for in particular if epsilon is equal to say 1 by 2. In particular, because it's true for each epsilon positive, epsilon is 1 by 2, then mod of fn x minus 1 is less than epsilon for all n greater or equal to capital. I can find this capital, and this means in particular it means that mod of capital nx minus 1 is less, sorry, it's 1 by 2 here now because epsilon was chosen 1 by 2. Okay, this is it. Now this gives mod of fn x. So it's less than this. Okay, it's less than this. This is equal to mod of 1 minus okay 1 plus, let's write here 1 plus fn x minus 1. Okay, it's still capital fn x, but you can apply triangle inequality. It's greater or equal to mod of 1 minus mod of fn x minus 1. Okay, mod of a plus b is greater or equal to mod a minus mod b, or mod of a minus b is also greater or equal to mod of a minus mod of b. That's equal to 1. Mod of 1 is 1 minus mod of fn x minus 1. Okay, name it here 1. Okay, but this mod of fn x minus 1 is less than 1 by 2, so minus times mod of fn x minus 1 will be greater than minus 1 by 2. Will be greater than minus 1 by 2. So this is greater than, which implies mod of fn x is greater than 1 minus 1 by 2, which is equal to 1 by 2. So that also means this, that also means if it is greater than 1 by 2, it is also greater or equal to. It also means that fn x is greater or equal to 1 by 2, which implies that, sorry, I should write here मेरे पास तो इससे ज़्यादा है ना, इससे ज़्यादा मेरे पास इंफॉर्मेशन है. I have this actually. I should write this here. I should write this is 1, not this. Okay. Let's erase this stuff. So I have more than this for all n greater or equal to capital N. So I should write everywhere small n. Okay. Small n, small n, small n, small n. Let's write this, because I think I want small n. Not this. Small n, small n. Okay. Let's see this next page. Should be here. Small n. Okay. But now this is greater than 1 by 2 for all n greater or equal to capital N. Okay, so this is greater or equal to 1 by 2 for all n greater or equal to capital N. So this means x belongs to then e small n, sorry, en for all n greater or equal to capital N, हर किसी इसमें है. So that means x belongs to actually e capital N intersection capital E n plus 1 intersection so on and so forth, and that's the notation for capital Fn. So this means x belongs to capital F. So thus for any x which is an irrational, it is in some Fn. So which means that this x, it belongs to union of such Fn's. कम से कम एक में है ना, so it is in the union. So it gives that so here it's this greater than इसको आप लिखिए by 1. Okay, it's by 1. The first line on this page, it's by 1. So therefore Q complement is subset of this union. So therefore Q complement is subset of union Fn, n runs from 1 to infinity, Okay, now we prove the reverse inclusion. Now let's take any point x in the union Fn, n runs from 1 to infinity. So this means x belongs to some Fn for some n. Okay, if x is in Fn, it means that x belongs, what's Fn? Fn is the intersection. So write it in the full expanded form. It's E capital N intersection E capital N plus 1 intersection so on and so forth. So this means that x belongs to E n for all n greater or equal to capital N, right? Because it is in E capital N plus 1 so on and so forth. So but this means mod of Fn x is greater or equal to 1 by 2, because whenever x is in En, it means that mod of Fn by definition of En, it's true for all n greater or equal to capital M. So that means the limit will be greater or equal to 1 by 2. So it's clear. So this simple, because it's always greater or equal to 1 by 2 for all n greater or equal to capital N, it means that the limit n approach to infinity Fn x is greater or equal to 1 by 2. But the limit of this function is the chi of x. So chi of x is greater or equal to 1 by 2. Now this here, it's a very important point. Chi of x has only two values, either 0 or 1. And here it's greater or equal to 1 by 2. Therefore chi x must be equal to, yes, it must be equal to 1. Yes, it's equal to 1. But when it's equal to 1, if x is irrational number, so which by definition, so this means x is in Q complement. So thus this union n runs from capital N or small n, and the same thing, it's F here. Okay, it's not E, it's F. Fn is subset of Q complement. So hence they are equal. Hence Q complement is union of these closed sets, countable union. Okay. So therefore Q complement, the set of irrationals, is F sigma set, is of type F sigma. Therefore Q complement, the set of irrationals, the set of irrationals is of type F sigma. A contradiction, because we know that Q set of irrational is not of type F sigma. So a contradiction as required. Any question? Yes? Any question? Then we conclude this.